We now go into 2024. This paper was written last year, 2024. So basically, in my introduction, I said we shall be dealing topic by topic. So we'll actually now focus on the electricity. There we go. Question, figure B.7.1 rather. B7.1 shows a circuit with two resistors in parallel connected to a 10-volt battery. So we've been given the voltage there, and these two resistors are connected in parallel. So basically, we can name this one as R1, this one as R2. So question A says, what is the effective resistance offered in the circuit? So basically, we just have to look at these two resistors which are connected in parallel. So we'll say the effective resistors, abbreviated as RE. Okay, effective resistors. Do not write it like this. Write it like the way I'm showing it to you here. So we are going to multiply R1 by R2. Then we add them, R1 plus R2. So the effective resistance is equal to, we know the value of R1, which is 3 ohms, multiplying by 6 ohms. We divide 3 ohms plus 6 ohms. So effective resistance will be, so now we multiply, we get 18 ohms, and we add, we get 9 ohms. And 9 into 18, we get 2 ohms. That is your answer, and you write it there. That's why physics is very simple. And our next question demands us now to find the current flowing in the battery. We need to find the current flowing in the battery. Okay, guys. So for us to find the current flowing in the battery, please let us look at these two resistors which are here. These resistors are connected in parallel. So in parallel connection, current differs and voltage is the same. So this resistor which is here receives 10 volts, and equally here it also receives 10 volts. But the current received by 3 ohms and 6 ohms differ. So meaning that if we find the current which is received by 6 ohm and the current which is received by 3 ohm, we add, we should be able to know how much current is being provided by the battery. So let us first find the current flowing in 3 ohms. Then later, we find the current flowing in 6 ohms. Then we add, for us to find now the current which is being provided by the battery, or the current which is flowing in the circuit. We are basing our understanding on this principle that current in a parallel connection differs and voltage in parallel connection is the same. What does this mean? This means that the 10 volt which is provided by the battery is the same voltage which is received by 3 ohms, and that is the same voltage which is also received by 6 ohms. Okay, but current differs. Why? When the resistance increases, current reduces. When resistance reduces, current increases. So there we go now. Remember that we have 3 ohms and 6 ohms. These are two resistors that we are dealing with. So we know that resistance is equal to voltage over current. And now we will basically find the current, which is voltage over resistance. So our current is equal to, so what is our voltage in that case? We have a 10. And we are first finding the current which is flowing in 3 ohms. So we have a 3 here. Okay, so current is equal to 3 into 10, you have 3.3, something like that. Yes, amps. Then again we find the current which is flowing in 6 ohms. Then we will have resistance is equal to voltage over current, and we have the current which is equal to 10 volts over the current which is the resistance which is 6 ohms, and our current is equal to 6 into 10, we have 1 point. There will remain a 4, we add a 0, then we have a 6, 7. Now, we want to know how much current is flowing in the circuit or is provided by the battery. Therefore, we'll have to add now. So the total current is equal to 3.3 amps plus 1.67. Our total current is equal to, what are we getting? We add 3.3, we add to 1.67. We are basically getting a 0. There we are getting another 0. There we are getting 5. So our current, therefore, our total current therefore is 5.0 amps. Then we go straight to the last question. Determine the charge flowing through the battery in